In this question we have to calculate the EMF of platinum electrode when 15 ml of 0.1 formula cerium4+ is added to 50 ml of 0.05 formula Fe2+. Which redox couple exists? Reason it out. Explain the chemical reaction. Which redox couple are you going to use in the Nernst equation? Please explain. To calculate this, first let us write the chemical reaction equation. So Fe2+ will react with cerium4+ to give Fe3+ plus cerium3+. Here iron is losing an electron and becoming Fe3+. Iron is getting oxidized, and cerium4+ is gaining an electron and becoming cerium3+, and that is cerium is getting reduced. So this is the chemical equation. Now 15 ml of now at 15 ml of 0.1 formula cerium4+, what happens? First let us calculate the amount of Fe3+ present originally. Amount of Fe3+ present originally is equal to, amount is equal to concentration into volume. We know the concentration of Fe2+, that is present originally. The concentration of Fe2+ is equal to 0.05 formula into volume, it is 50 ml. Originally there is 0.05 formula of Fe2+ and there is 50 ml, and which gives us 2.5 millimole. So this is the amount of Fe2+ which is present originally. From this we can calculate the concentration of Fe2+. So the concentration of Fe2+ is equal to amount divided by volume. So the amount we have calculated 2.5 millimole divided by volume. So the volume here would include the 50 ml of Fe2+ along with the 15 ml of cerium4+, which is equal to 50 plus 15 ml, which is equal to 2.5 millimole divided by 65 ml, which is equal to 0.03846 formula. So the concentration of Fe2+ when there is 15 ml of cerium4+ is 0.03846 formula. So this is one part of the calculation, and the next part of the calculation would be to calculate the amount of concentration of cerium. So the amount of cerium present, cerium4+ present, is equal to the concentration into volume. The concentration is given in the question that it is 0.1 formula into the volume. We are adding 15 ml of cerium4+, and therefore it is 15 is the volume, which gives us the amount is equal to 1.5 millimole. Now from the volume, and from the amount we can calculate the concentration. So the concentration of cerium4+ is equal to the amount of cerium4+ divided by volume. Now the amount of cerium4+ is 1.5 millimole divided by the volume, which is the 50 ml of Fe2+ and the 15 ml of cerium4+, which is equal to 65 ml. So the concentration of Fe4+ is equal to 0.02307 formula. Now we have figured out the concentration of Fe4+ and the concentration of Fe2+. Another point to note is the amount of cerium and Fe2+ that are present. So the Fe2+ is 2.5 millimole and the amount of cerium4+ is 1.5 millimole. Now we have to notice that 1.5 millimole is less than 2.5 millimole, which means that the amount of cerium present is less in this reaction, and therefore cerium will be a limiting reactant, which will be useful in the further calculation. Now we know from this reaction that the amount of cerium used, cerium4+, is equal to the amount of Fe3+ that is formed, and therefore we can write that amount of cerium 4 plus is equal to the amount of Fe3 plus. Okay, therefore the concentration of cerium 4 plus is equal to the concentration of Fe3 plus, which would be equal to this value. The concentration of cerium 4 plus is equal to 0.02307 formula. Okay, so this is the one part of this is the next part of the equation, calculation. So now after we find out the concentration of the cerium 4 plus, we need to find out how much of the Fe2 plus is remaining. We need so this Fe2 plus is becoming Fe3 plus, and therefore the amount of Fe2 plus would reduce. So we need to find how much of Fe2 plus is remaining. To find out the amount of Fe2 plus remaining, amount of Fe2 plus remaining is equal to amount of Fe2 plus present originally minus amount of Fe3 plus formed. Amount of Fe2 plus present originally is 2.5 millimole, and the amount of Fe3 plus formed is equal to the amount of cerium 4 plus that is present. Therefore, the amount of Fe2 plus formed is equal to 1.5 millimole. We can write it as is equal to 2.5 millimole minus 1.5 millimole, which is equal to 1 millimole. So the amount of Fe2 plus remaining is equal to 1 millimole. Now we need to find the concentration of Fe2 plus remaining. We can find this from the amount. So concentration is equal to amount divided by volume, which is equal to 1 millimole divided by 65 ml. The 65 ml comes from the 50 ml of Fe2 plus and the 15 ml of Ce4 plus, which is equal to 1 divided by 65, which gives us 0.01538. Formula is the unit for concentration here. Now we have figured out the concentration of Fe2 plus remaining, and we have also found out the amount of Fe3 plus. The amount of concentration of Fe3 plus, which is equal to 0.02307, and the concentration of Fe2 plus, which is equal to 0.01538. Now next we have to understand the next part of the calculation. Since, as I have mentioned before, since Ce4 plus, the amount of Ce4 plus is lesser than that of the Fe2 plus, therefore Ce4 plus is a limiting reactant in this equation. Therefore the amount this Ce4 plus will get completely consumed. This will get completely consumed and there will be no more Ce4 plus present. It will only be Ce3 plus, and therefore it is we need to understand that Ce4 plus Ce3 plus redox couple does not exist, as Ce4 plus gets completely consumed and there is only Ce3 plus. So Ce4 plus Ce3 plus redox couple does not exist. But we have also seen through the calculation that there is the concentration of Fe2 plus is around 0.03846 and the concentration of Fe3 plus is 0.02307. So there is significant amount of Fe3 plus and Fe2 plus present. Therefore Fe3 plus Fe2 plus redox couple exists. Therefore, this is the redox couple that we will be using in the Nernst equation, and we will not be using the Ce4 plus and Ce3 plus. Another equation that we need to note is what happens after the Ce4 plus gets completely consumed. When Ce4 plus gets completely consumed, there will be only Fe3 plus Ce3 plus. Now this will react to give Fe2 plus Ce4 plus. So Fe3 plus will gain an electron and become Fe2 plus, it's getting reduced, and Ce3 plus will lose an electron and become Ce4 plus, Ce3 plus gets oxidized. So for this, we can write the Nernst equation. The Nernst equation is given as the potential at the platinum electrode is equal to EFE, which is equal to E naught of Fe3 plus Fe2 plus, the standard potential of the Fe3 plus Fe2 plus redox couple, minus 0.0591 divided by N log of the concentration of Fe2 plus in the product side, Fe2 plus, divided by the concentration of Fe3 plus in the reactant side. Okay, now it is given that the standard potential of Fe3 plus Fe2 plus is equal to 0.77 volt and the N factor is equal to 1 because only one electron is being used to reduce Fe3 plus to Fe2 plus. And now the equation can be written as is equal to Fe, which is equal to, this one is equal to 0.77 volt minus 0.0591 divided by 1 log of, from our first set of calculations, we have the concentration of Fe3 plus that remains is equal to 0.01538 formula, which is equal to 0.01538 divided by the concentration of Fe3 plus is equal to the concentration of cerium-4 plus, which is equal to 0.02307. We'll write that down. 0.02307 formula, which is equal to 0.77 volt minus 0.0591 log of, when you divide these two terms, we get 0.6667, which is equal to 0.77 volt minus 0.0591 log of 0.6667 is equal to minus 0.17606, which is equal to 0.77 volt minus, this becomes plus, minus and minus becomes plus, which is equal to 0.010405, which is equal to 0.780405 volt. Okay. Therefore, we can conclude that the EMF at the platinum electrode when 15 ml of 0.1 formula cerium-4 plus is added to 50 ml of 0.05 formula Fe2 plus is 0.780405 volt. Okay. So an important points to note is that which redox couple exists. To just recall that the redox couple which exists is Fe3 plus and Fe2 plus redox couple. Since the amount of cerium-4 plus is lesser than that of Fe2 plus, the reaction goes to completion and there will be no cerium-4 plus present anymore, and only cerium-3 plus will be present as the electrons are being consumed. I mean electrons as it gets reduced to cerium-3 plus, and therefore only the Fe3 plus Fe2 plus redox couple will exist. And the next question is the chemical reaction. I've explained that, and which redox couple are we? The redox couple which we're going to use in Nernst equation is Fe3 plus Fe2 plus. And to understand the chemical equation again, Fe2 plus is getting Fe2 plus will lose an electron and become Fe3 plus, which means that it is getting oxidized, it's undergoing oxidation. And Fe4 plus will gain an electron and become Fe3 plus, it's getting reduced. Okay, so this is the chemical equation. And the other chemical equation which we used is this one, where we have written that Fe3 plus, which is present after, this is after the cerium 4 plus gets consumed. So we have a cerium 3 plus that is being existing, the cerium 4 plus is not there, and Fe3 plus, and Fe3 plus will gain an electron from cerium 4 plus and become Fe2 plus, that will get reduced. And cerium 4 plus will lose an electron and become cerium 4 plus, this is getting oxidized. So this is the problem. I hope you understand. Thank you.